Hi folks, it's Mr. Roy. We're going to do some graphing on Excel. Here we go. Okay, I want to start with just a very basic example. I don't want to think about like weird data or data that's got a lot of information in it yet. I just want to think about something really basic. So what I did here is I wrote into Excel a table of X and Y values. And with Excel or any spreadsheet program, you can just type whatever you want into the cells. I could type high class into the cells and then hit enter and there it is. Um, but I don't really want to do that. I kind of want to use numbers. Now you notice the X and the Y have justified to the left side of the box because it's recognizing them as letters. And everything else, the numbers are on the right side of the box because it's automatically recognizing them as numbers. And so Excel can kind of tell a little bit about what I'm doing here. I also, if I want to have a bit more room, I can up here at the top grab and I can shrink or expand my columns. And I can also on the side here grab and shrink or expand my rows. I can also right click and then go insert or delete to put in or get rid of a column. And I can also right click here and I can insert or delete my rows. But I don't want to do any of that. What I really want to use this for is graphing. So here we go. Let's do a little bit of graphing. So I'm going to grab my data here. I'm going to be really careful not to grab my X and Y values. Okay, I'm going to leave them alone. I'm not going to grab my X and Y values. And then I'm going to say I want to insert and I want to do a chart. Now, the kind of chart I want to do is a scatter plot right here. So I don't want any lines put into it yet. I'll deal with that later. Okay, so I'm going to, again, I'm going to grab just the numbers, not my X and Y, not my labels. I'm going to go insert scatter plot. Boom, and I got a nice little graph. Now this is a pretty good start, but we always want to improve our graph a bit by labeling things properly. So I'm going to call this, let's say, Y values versus X values. Now that's not a very good title because I'm not dealing with context here yet, but I just want to show you how you would type that in. And now I want to add some things to it. So there's a couple ways to do that. I can either click the plus button here. That'll add some chart elements. Now if I'm not on the chart, you won't be able to find it, right? But if I'm clicked on my chart, all of a sudden I can see that plus. There's also a button up here called Add Chart Element. So I can add a chart element and that'll do the exact same thing, right? So you can click either of those. I'm going to click the Add Chart Element up here. And okay, I want to add some titles on my axes. So I want to add one on the horizontal, and I also want to add one on the vertical. So I'm going to add chart element and axis titles. The chart title is already there. And I don't want to do error bars, grid lines, stuff like that. I don't want to mess around with those yet. So let's put on our titles. This one is our x-axis, so for now I'm just going to call it x. This would be our independent variable. The one we're changing on purpose. Often time is the independent variable. This, on this axis, our y, is our dependent variable. That's the one we're like measuring to see how it changes. Okay? Now, I want to do some regression with this chart. So I'm going to go add chart element, and I'm going to go trend line. Now, I got a couple of options. Right now, there's none on there. I got linear, exponential, linear forecast, moving average. I don't know. I don't want any of those. I'm going to go more trend line options and see what I got. So over here, I've got a couple of options. You might, if you started, say, on the paint bucket here, I don't want that. I don't want this pentagon. I want this thing that looks like the chart for my trend line options. And I got a lot of different options on here on for my trend lines. The key things I want to include is I want to click display my equation on the chart. So I'm going to click that down here. And all of a sudden it does the equation for my line of best fit. And I want to display my R squared value on the chart. Now an R squared value is going to tell you, and I can move that around if I want to see it better, that's going to tell you how close this is to the actual, let me get some more my options back here. That's going to tell you how close this is to, in this case, a straight line. So how close are my data points to my line of best fit? They're pretty close, 0.9678. That's pretty close to a straight line. 1 would mean the lines are on a perfect straight line. 0 would mean the dots are completely random and are not in a line, as far from a line as you can possibly be. So we're in between a 0 and 1. This is pretty close to a linear relationship. But maybe there's a better one. So we've got a couple of options here that we can try. The ones we're most familiar with are linear and quadratic. Now quadratic is not on here because quadratic is a second order polynomial, right? So what I got on here is a second order polynomial, and I can put my r squared value and my equation right here. And it looks like that one is much better. Now I'm losing my options here, so I'm going to go back to here and go back, say trend line, more options, come on back, there they are. Okay. So looks like now I got an equation for a quadratic. It's a messy one, but that is a better fit. The r squared value is 0.9985. So that's much better. That's almost 1, meaning this relationship is very close to being quadratic. Okay, so maybe a quadratic relationship is what I want, or maybe exponential is the one that I want. Now this is getting pretty messy here, so I'm actually just gonna get rid of my chart. I'm gonna start over, so we can kind of start from a clean slate. Again, insert, scatter plot, there it is, and I'm gonna go trend line, options. So let's try exponential. That's what that one looks like. Or we could try power. That one doesn't look great. Moving average, we're not going to use. Now for polynomial, I could just keep increasing the number until it like fits the line perfectly, but at a certain point, like a 6th degree polynomial, x to the 6th, that's not going to really make a lot of sense. Most relationships in the real world aren't like that. So I'd like you to, unless you can provide me a good reason otherwise, stick to polynomials of 2nd degree, so quadratics. If you can give me a good reason otherwise, then we can definitely talk about it. But okay, so options we've got are exponential, linear, logarithmic, polynomial order 2, power. And which one of those is going to be the best, right? So there's our r squared values. Looks to me like 0.9946 and 0.9985. So exponential and quadratic are our best fits, and quadratic is the better one of the two. So I finished my chart. I'd have to relabel the axes and stuff, but I finished my chart. You'll see that that was pretty quick. I've got the equation for my curve of best fit, and I've also got my r squared value, which is a very high one, meaning a high degree of confidence. So I can make a prediction about what my next point will be using my equation for y equals 0.5714x squared plus 0.3714x plus 2. Let's say I wanted to know what the value of y would be when x is 14. Well, that's way off my chart, x value of 14. But I could use my equation that I have here. I could plug in a 14 wherever I see an x, and I could get an answer for that. Okay, so that's the basics of doing the chart, putting on the r squared value, and our equation for our line or curve of best fit. Now what I want to do is try this with the data that I collected in that last video about students in Indigenous language programs. So I want to get that data. So I deleted the row that's in between that was in between 6 and 7. It was in the way, and I want my data to be all together in one group. Now this is a sideways group of data. One option is I could take all my year values and write them down here, and then I can take all my student enrollment values and write them down here as my x and my y, and then I could grab them and make a graph. That might be a great way to do it. But let's see what happens if I just grab the data that's right here and give it a try. Okay, so I'm going to grab all that data. I'm not going to grab any of the labels. Although sometimes if you grab the labels, it'll put them on the chart. It's a bit finicky, but let's give it a try and just see what we get. So I'm going to go insert, scatter plot, and you can see it tried to figure out what to do with the words, and it didn't really know, so it put like 1 in as a title. So I'm just going to get rid of that, And I'm going to start over and I'm just going to grab the data here. And I'll go insert over to scatter plot, and here's my graph. Let's make that a bit bigger so we can see it. Looks pretty nice. If I want to increase the size of my my information over here, I could make that bigger. It depends. And I can also change where it's going to appear on the graph. If I want, what do I want my minimum and maximum to be? Right now it's defaulting to starting at 0 and going all the way to 10,000, and that probably makes sense. But if I want to change that, I could do that. I would be able to do that. Okay, so I'm going to get rid of that and just have a look at my chart here. I could label this, and let's do that. Let's label this change in student enrollment in Indigenous language programs in Ontario. 2005 to 2019. Okay, so that describes what's on the table, I think pretty clearly. Let's add a chart element. So I'll click up here and I want some axis titles. And I'm going to call my vertical one here. Let's call that student enrollment. And now here's a tricky thing. On my x-axis, I notice it's like, it's not giving me the years, 2005, 2006, 2007. If I wanted to have it do that, I could write out my columns again, and I could get it to do that for me. The problem is, though, your graph may start at 0 and then go all the way to have this giant gap in between the year 0 and the year 2005, and we'd have to get rid of that using our mins and maxes. So that's a bit annoying. I could also just describe this as years after 2004, 2005 school year. So the 1 on there represents the first year after the 2004-2005 school year. The 2 on there represents the second year after that. So that would be a fine way to label it. Now this data, I want to see what kind of trend line I can get out of this, right? So let's give that a shot. So let's go add chart element, trend line, more trend line options, boom. Okay, it's putting in a line of best fit, and I need to click my little like graph thing here. It's putting on a line of best fit. To me, the line does not look great. What about an exponential curve? That looks a little better. What about a logarithmic curve? Ooh, that looks terrible. What about a quadratic? That's pretty good. What about a power? That looks bad. Okay, so of those options, to me, I thought exponential and quadratic, polynomial order 2, those look the best. But let's see what our r-squared value is going to look like, because that'll help me assess. So that r-squared value is 0.9769, 0.9689, 0.78, ooh, that one's bad, 0.982, 0.8452. Okay, so it looks like 0.982 and 0.9769 are my best. So the ones I thought looked the best, I was correct. But looks like, again, this is a quadratic relationship. That's the closest one, is a quadratic relationship. Let's move my r-squared out of the way here so I can see it a little better. And let's make it bigger. Let's make it like 16 so I can see it a bit better. Good. And now let's also put on my equation. Where's my equation? Display equation on chart. There we go. And it looks like it's doing that funny thing where it's trying to do 2 lines at once because it thinks I'm doing a new one. So I might have to start from scratch, right? And say like, oh, that's annoying. But now I know I want to do my quadratic, right? I know that's the one I want. So I can grab my data again. I can go insert. I can go scatter plot, make it nice and big. And I know, okay, I want to add in a trend line, and I know that my best trend line, because I tried it out, is going to be polynomial order 2, put my equation and my r squared value. Good, okay. So now I've got my equation and my r squared value. Now, what does that equation mean, right? We look at that equation, I'm like, well, what does that even represent? I can use this equation if I am, say, the director of a school board to make predictions about the enrollment in Indigenous language programs, say, in the year 2030. So let's make a prediction. How many, so let's say year 2029, 2030. I have to say, okay, well, how many years after 2004, 2005 is that, right? I figure out how many years that is, and that's the x value I'm going to plug into my equation. So I plug that x value into my equation up here. Y equals 14.178x squared plus 223.9x plus 3,526.6. I'm going to plug that in, and I'm going to get my answer. And that will tell me a pretty good indication of what I can expect as my enrollment in Indigenous language programs is going to be in the year 2029, 2030. So this allows for me to do future planning and not just be reacting to stuff, but planning to where these trends might go. These trends in Ontario, I think something that's really positive is this big increase in Indigenous language programs in schools. And so say as someone who's a director of education again, I would use this data in order to inform my decisions about how the programming is going to go forward. I would recognize this as an area of growth, and I would recognize here's the trend where it seems to be going. I need to plan for that. Okay, so that's how we would use these graphing options on a real graph. Now, if I want to stick this somewhere, I can do that, right? I don't want to copy the whole thing. I just want to click on my graph, and I'm going to go right click and go copy. And now I'm actually going to be able to paste this in a Word document. Okay, so I'm going to show you. Okay, so I've opened up an empty Word document. And again, I'm going to just click on my graph, and I'll right click it, and I'll say copy. And I'm going to go to this Word document, and I've typed a whole bunch of stuff, blah, 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 blah. Okay, I'm ready to put my graph in. I'm going to hit Control V, and there's my chart. Now I can shrink this down if I want, but I'll notice some things kind of stay the same size. So you kind of want to, you might have to experiment with this a little bit. Maybe I want to shrink that down a little bit to make it look better on here. You might have to experiment with this a little bit because the chart doesn't come in as a still image. It will actually be changeable in certain ways, even after you've pasted it in the Word document. But this is what I'm looking for in your final report. You've got this clear chart with clear labels, your equation, your R squared value that was the best one you could get, and that this shows me that you've got the clear data and you've made some clear conclusions from it. And you, in this case, recognize that it seemed to be a quadratic relationship was your best one. Okay, I hope that's been helpful. Now we know better how we're going to use Excel. Let's go forward and let's work on our culminating project.